Yes.
Yes, give us just a second to get the presentation up, and
whenever you're ready, just say next slide and I'll move the slides along.
Okay, thank you very much. This is Tomoki Nakamura. I'm from Japan. I'm a leader of a remote sensing consortium of the MMX mission. Today, I'd like to introduce MMX mission summary. MMX is sample return mission from Martian moon Phobos. The spacecraft will visit Phobos for 2.5 years and perform landing on Phobos twice to collect samples, then goes to Deimos for multiple flyby. Next slide, please. The goal of the mission is to clarify the origin of Phobos and hopefully of Deimos, both by remote sensing observation and return sample analysis. There are two competing hypotheses for the origin of Phobos and Deimos. One is they formed by giant impact on the Mars, and the other model is they are captured asteroid. We have to solve which model is correct by remote sensing observation and return sample analysis. By doing that, we can make a progress in our understanding of planetary system formation and also primordial material transport across the snow line in the early solar system. Next slide, please. Thank you. A recent numerical study succeeded to make Phobos and Deimos by giant impact on the Mars. The results of simulation indicate that the Phobos should have formed 4 billion years ago at orbit around 6 Mars radius from the Mars, and then moved to the current orbit gradually. Next slide, please. This shows spacecraft configuration. A wide range of trade-off study is now underway to develop the spacecraft configuration and the specifications. Next slide, please. This shows mission profile. The spacecraft will be launched in 2024 September, and then arrive at Mars in 2025 August. Then the spacecraft will be orbiting on quasi-satellite orbit around Phobos, and then try to land twice. And after that, the spacecraft moved to the Deimos for multiple flyby. And the spacecraft will departure Deimos 2028 and coming back to the Earth in 2029. Next slide, please. We have 7 remote sensing apparatus. First one is gamma ray neutron ray spectrometer, which will be provided by a Meghani team, Johns Hopkins University, which is designed to measure elemental composition of Phobos. And then we have a visible camera for imaging. And we have 2 spectrometers for visible and near-infrared. The near-infrared spectrometer will be provided Macro Omega team from France. And we have LiDAR and mass spectrometer and a dust counter. Next slide, please. This shows quasi-satellite orbits around Phobos. We have 5 orbits with different altitudes for the observation of Phobos, for science and also for the landing site selection. The shortest radius is 100 kilometers, 50, 30, 24, and 20. And the orbit are ellipsoidal, and the long and short axes are fixed. Therefore, submerged, and opposite points are always lowest altitude. Next slide, please. This shows timeline for the tentative operation plan for Phobos and Deimos from 2025 to 2029. We developed this science operation plan considering many factors such as distance to the Earth and the Sun, and also communication time or the surface temperature of Phobos. We divided 3 years into 5 phases, and we used first 4 months to check out apparatus and also to obtain a shape model. And then a solar conjunction is coming. After the conjunction, we have used 8 months to take spectroscopic and elemental data for landing site selection. After that, the most important period is coming for the touchdown. When the communication time is shortest and surface temperature of Phobos is lowest, therefore very good timing for touchdown. And after the touchdown, we will perform some important scientific observation of Phobos. Then again, solar conjunction coming. At that time, we will move to after that, we will move to the Deimos orbit for the multiple flyby observation. Next slide, please. We will perform 2 times landing on Phobos surface. Spacecraft will stay on Phobos only for 3 hours because Phobos one day is 7.5 hours, and everything, including sample collection and detailed observation of landing site, has to be done in Phobos daytime. Therefore, we have only 3 hours. Next slide, please. Return sample analysis will give us conclusive evidence to identify which model, capture model or giant impact model, is responsible for the origin of Phobos Deimos. For instance, oxygen and chromium isotope ratio are clearly defined between Martian material, which favors giant impact model, and carbonaceous chondrites, which favors capture model. We can distinguish these 2 features by return sample analysis, and therefore we hope we can terminate the discussion of origin of Phobos and possibly of Deimos by remote sensing observation and return sample analysis. Next slide, please. MMX is not the first spacecraft visiting Phobos and Deimos. We have many important previous data by previous missions. And based on these previous data, we like to perform the following activities before launch 2024. First one is we'll have to develop a precise shape model. And then we will select possible landing sites, 20 sites or more sites. In order to facilitate these activities, the new observation by ongoing Martian missions and also the international collaboration is very important. Next slide, please. This is a list of international collaborations. NASA will provide a Megane team and a gamma ray neutron spectrometer, also a P sampler system, and a deep space network. ESA will provide K-band communication system. CNES macro omega, which is a near-infrared spectrometer, and also a LOBA system together with the DLR. And Italy and Russia will also support MMX mission. We really appreciate these cooperations. This is all I prepared today. Thank you very much.
Thank you. Do we have questions?
Tomoki-san, this is Paul Abel. Can you hear me?
I can hear you, but I cannot identify your voice clearly. So please say again by Chairman. I'd like to ask the Chairman to. Okay. Okay. Good. Hi.
Tomoki-san, this is Paul. The question for you is, can you tell us a little bit more about the budget situation for MMX?
Budget situation? Maybe I'm not quite qualified to answer such questions.
Okay.
Sorry.
Thank you. Other questions? All right. Thank you very much.
Thank you.